I am going to use distributive property is correct. Rachel, can you tell me what steps I could write using distributive property? No? Oh, you just know that it's negative 2x squared, right? Oh, you know, okay. Alvin?
We distribute out x.
Right, so what does that mean? Gemma?
Oh, okay, so you do like negative 3, like in parentheses.
Yes.
negative 3
Good.
plus 1
Uh-huh.
divided by x squared, and then 5 plus negative 2 times x.
That's exactly right.
And
And plus negative 4, because that doesn't have any length. Do you see how this is using the distributive property? And do you think I want to see the steps? Yes, I do. Even this extra step. Just for this section. Okay, I want to, from next section, I'll let you just write. Okay, but for this, tonight's homework, I want to see the step. Because this will help you eliminate some of the silly mistakes that you guys make. Okay. So Raymond, what does that become? Who can tell me what this becomes? Jamin? Negative 2x squared. Now, if you don't believe me, multiply x squared times negative 3. What's that, guys? If you distribute, if you don't believe this step, watch this. What's x squared times negative 3? Negative 3x. Plus, what's x squared times 1? Yeah, isn't that what we did? And Gemini is correct. That still simply becomes negative 2x squared plus 3x minus 4. And we don't normally write it as plus negative 4. We just simply write that as minus 4 at the end. So this is the sort of things I want to see. I know that a lot of you could do this in your head, but I would rather have you take one more step than get these ones wrong by making silly mistakes. Okay? Alright, so any question? Go ahead and try this one yourself and show me those steps, even though they're pretty simple. Go ahead, everybody try. So first of all, I would like to change everything to addition. So Kaylin, can you tell me what to write?
so 4m squared plus 5mn plus negative m squared plus 3m squared.
That's right. And Raymond, what are my like terms?
The like terms are 4m squared and negative m squared.
That's right. What about 5mn and 3mn squared? Aren't they like term, guys?
No.
Do not? Why not? I got mn over here. Yeah, Ryan.
Because 3mn is squared.
Yeah, you got mn squared. They don't look exactly alike, do they? Okay, well, obviously this one has exponent of 2 for n, and this one has exponent of 1. That's invisible 1 too, isn't that right? That's it. Anyway, so who would like to then tell me what my next step is? Who haven't I called today? How about Stefan? Tell me what to do next.
You simplify 4m squared and negative m squared to 3m squared.
Oh, yeah, before I do that, can I use the commutative property of addition first and rewrite them, rearrange them this way? Right? And associate them. Then, yeah, can you tell me what to write using the distributive property next? Yeah, I know that this becomes 3m squared, but what kind of work do you need to show?
4 plus negative 1 in parentheses and then times m squared.
That's right. Does that make sense? And a lot of you didn't put this thing down. This is the work I want to see, guys. Okay. Does that make sense? And this is why we get, what's 4 plus negative 1, guys? 3, and that's what we get. How many people got this polynomial? Now, if you didn't, do you understand what went wrong there? If you didn't get that, any question? Okay, good. Yeah, some of you didn't write this in the same exact order as I did. You wrote. So whenever let me explain to you real quickly. Whenever there's more than one variable, you choose one variable. In this case, I'm going to choose m. What do you suppose I choose m instead of n? M comes before n in alphabetical order, and you write with the highest exponent of that variable that you just chose. So I wrote m to the second power, m to the first. Here, this is m to the first too, so it wouldn't really matter which one you write first, but we're going to explain later why I wrote 3mn squared later. But that's how you do it, okay? So if you have more than one variable, choose one variable, preferably the one that comes before the other one, and write them with the highest exponents to the lowest of that variable. Does that make sense? All right, now let's look at example 3. Sometimes they write or they give you this addition vertically. And does that change anything? Not really. It just, but it does. Sometimes it does make it easier. But the way I do this is kind of notice. First of all, I have subtraction. Do I like subtraction? No. So I'm going to rewrite this addition, and also, yeah, question. Oh, it says 2a squared plus ab plus 2b and 4a squared minus 3ab plus 9. So it says add these two polynomials. And the way I like to add them, you could do them vertically if you like. The way I like to do this, first I change everything to addition. Then I line up with the like terms. Thankfully, these first two terms are like terms, and so are these two. What about ab and 9? Are they like terms? No. Guess what I'm going to then do? I'm going to actually skip them like this. You see how I skip like because I don't want to write 2b and 9 together because they're not like terms. So I basically line up the like terms together vertically and then just add them together. And of course, make everything its addition. So Alvin, tell me what to write. What does this become? Using the distributive property, I know that 4a squared plus 2a squared is 6a squared, but using the distributive property, what should I write? Parentheses. Good. And there's an invisible 1 again, right? The coefficient of AB is 1, isn't that right, guys? So what do I write, hand? I mean, Albert? That's right. And of course, AB just kind of becomes AB plus 9, right? There's really 0 if you want to think of it. Okay, so this is what we get. And of course, the answer is 6a squared plus negative 2. Of course, 1 plus negative 3 is negative 2 in there, right? Plus AB plus 2b plus 9 is your. And of course, using the definition of subtraction, you don't normally leave it that way. You just write 6a squared minus 2ab plus 2b plus 9. Okay, does that make sense? And so far we've been adding. Now they give us something to subtract. Okay, we got two polynomials to subtract. And this sort of problem is the one where people make a lot of mistakes, silly mistakes. That's why we're doing all this showing work and things like this. Okay, so I got 3a cubed minus 2ab squared quantity minus a cubed minus 4ab minus b cubed in parentheses. Okay, what do you think I should do so that I don't make silly mistakes? Ali?
You should distribute well, first you should change it into
Good.
addition.
I should first write everything into addition. Now, how many subtraction symbols do you see, guys? A lot. How many of them are there? Benjamin? What? You see 4 of them? Me too. I see 4. Here's one right here. 1, 2, 3, 4. What's the major subtraction symbol that you see? The one right in the middle, right? Okay, so how do I rewrite this as addition? Because if you could do this successfully, this problem becomes really, really simple. Who wants to try? Okay, Melissa.
3a cubed plus a negative 2
Good.
plus
Plus
a negative 8 cubed
what?
plus a negative 8
Plus negative
cubed
a cubed. So you could just change this one into plus without doing anything?
plus a negative.
Plus negative. What number is really there, guys? 1. So when you change subtraction to addition, just like how you did it here, you change subtraction into addition and write the opposite of the number next to it. You change the subtraction into addition, and what's next to this subtraction symbol? 1. So what that 1 becomes? Negative 1, doesn't it? Right. Doesn't that become this way? So that's the key step that you got to do correctly. Well, I wrote down the invisible 1 here. I'll show you why in a moment. But notice I changed that subtraction to addition, and since there was 1 there, opposite 1 is negative 1. Right? Times, and then of course there were 2 subtraction, I just changed them into addition. That one's pretty straightforward. Does that make sense? Why do you suppose I did all this work? Because now we have to then what? We can't find the like terms yet because we have a bunch of parentheses. We got to get rid of these parentheses by, how do you get rid of it? We have to use the distributive property. We're going to distribute 1 here. What happens when you distribute 1? You get, well, something happens. It's not nothing. What happens as you distribute 1? Yeah. Say it again? Yeah, you could use the identity property of multiplication and you get the same exact thing on the left, except what happens to the parentheses? It goes away. What about -1? When I distribute -1, what happens to this parentheses? Goes away again, but you get opposite of what you got here, right? So who could tell me what my third step then is going to be? How about William Lee? Tell me what I get on the left side, William. The first 3a cubed plus -2ab squared, and without the parentheses, right? Plus then what, William? Good. Is that all? Plus what? Plus what? Plus. You gotta distribute -1 to this one now. 4ab plus b cubed. You see how it became opposite of whatever we had in there? Because you're distributing -1. Positive a cubed became negative a cubed. Negative 4ab became positive 4ab. Negative b cubed became positive b cubed. Right? Because we distribute that -1, right? And so of course, we can now, since look at all the parentheses, now we can move things around freely because everything's addition, and we could use the commutative property of addition, right? So I'm going to rewrite this as, notice I have 2 like terms, okay? I mean, a pair of like terms, 3a cubed and -a cubed. What about the rest of these? Do we have any other like terms? No. Okay. Even though they ab squared, this is ab only, so they're not like terms. And so, what's my next step? 3a cubed plus -a cubed, that becomes, Vlad? What's my next step? Say it again? 2a cubed, right. Before I write 2a cubed though, what steps do I want to see? 1, 2, 3. Gianni? That's right. There's that invisible 1 again, right? 3 plus -1 times a cubed. That's a cubed, right? Does that make sense? Now, this is why, Bled, we get 2a cubed plus -2ab squared plus 4ab plus b cubed. Is that right? And of course, we don't want to just leave it this way. We're going to use the definition of subtraction and rewrite 2a cubed minus 2ab squared plus 4ab plus b cubed. Okay? Does that make sense? Do I want to see this step, guys? Right here? Okay. I want to see this step for tonight's homework, at least, okay? Any question? The reason why I skipped number 4 is because, well, it's something you got to be careful. And you don't get this too many times. You may get this. There's a couple ones that looks like this. It says subtract 2x squared minus y squared from 5x squared minus 7xy plus 2y squared. Okay? If they ever give you this, and like I said, they don't really give you too many of these, but if they do, there are 2 things you got to be careful of. First of all, anybody see what a common mistake for something like this is? Oh, one person really wants to tell me. You sure you want to tell me? Okay, what do you think, Ali?
It's not subtracting 2x squared minus y squared from the other one.
That's exactly right. It's not the first polynomial minus the second. Gemma, what is it?
Wait, no, that's not what I want to tell you. Ask someone else for now.
Okay. Oh, that's not okay. Okay, so you're right. Well, what is it then? Aaron, it should be what?
It should be 5x squared plus 7x plus 2y squared minus 2x minus y.
That's right. It's the second polynomial minus the first. Isn't that right? Because think about it. If I say subtract 2 from 5, do you do 2 minus 5 or do you do 5 minus 2? Hello? Did I?